Here's another fundamental concept. So operations, they're symbols that change values. We can think of it as a value x, which is the input, which is also known as an operand when we're dealing with operations. And we're transforming it to x prime, which is the output. I know that there's a better one, kind of looks like that. We're just going to do it with this, comma, this little operation symbol. I'm going to call it op for later. So for operands, they're pretty special, and operations, they have their own arity, number of operands. Okay, a null-array operation is just a constant. It is just the same. Values, they just stay the same. As for unary operations, it gives you your classic absolute value of x, going for the integer that is below a certain value, which is the floor function, and then the ceiling function, which is the integer that is above a certain value. Yeah, you just have to look them up for now. And then you have your sine, cosine, tangent for trigonometric operations, and their inverses as well as their, reciprocals. And also there are the hyperbolic operations, sine, sinh, cos, hyperbolic. Okay. Looking for binary operations. There are your favorite addition, subtraction, multiplication, division, exponentiation, logarithmic. And then there's hyper operations. We have mod. The list can go on. There are some inverses, or there's the additive inverse is subtraction. Multiplicative inverse is the reciprocal. So in the way they're opposite, they are opposites, so on. Now, as we're dealing with ternary operations, it'd be a lot complex because we're dealing with three values, or three inputs. You can talk about functions at this point. Functions are a bit specific. Okay, a. So for vectors a, b, and c, a times the dot product of the quantity b cross product of c. You're taking the cross product first, and then we're dealing with the dot product after. If this equals 0, that means three of these vectors are coplanar. They're on the same plane. When we're dealing with addition, we're going to have a nice pattern with all numbers. In the, let's just say, the real numbers. So for now, we have a, and we're going to add 1 to it, b number of times. We're going to get a plus b. This is very true. If we set b to equal a, what happens? A plus 1 plus 1 plus 1, continue, and actually this would be a, and then that would equal a plus a. So for 4 plus 4, it's really, which is our a value, 4 plus 4, or actually 4 plus 1, plus 1 plus 1 plus 1, which is just 4 times, that is the same thing. Now for multiplication, when we set a equal to a, or rather b equal to a, we had a plus a. So this repeated addition of a is multiplication. Multiplication, which is part of the pattern. So multiplication. This is where we have a plus a plus a plus a, so on. That would give us a times b if the amount of repeated addition of a is b. We have a dot b, or a times b, or a parentheses b. Either way, you need to know what you're doing. We can set b equal to a once more. We can just call this, we can just say b equals a, and then that would give us a times a. Now, we can go with exponentiation. Going with a times a times a, so on. We have that. B times, we'll get a to the b power. If this is equal to a, we get a to the a power. Now for tetration, which is a bit more higher, it's worth a lot more than exponentiation. Now we have a to the a power, and so on. We have that. B times, we'll get v tetration a. Or in other words, using the little up arrow, a up b. We can look at this pattern once again. Let's talk about exponentiation. Here we go. We have 4 to the third power, which is 4 times 4 times 4, which is 4 plus 4, 4 plus 4 plus 4 plus 4, and then, yeah, that would be, I guess, 12 more times, and then we'll get that answer. Let's do the first 4, second 4, third 4, all the way to 4 to the 16, or 4 sub 16. And then we have 4 plus 1. Hold on. So this is the same as this one right here. 4 plus 1 plus 1 plus 1.